Hi, I'm Ben with Filthy Motorsports, and in this video, we'll be discussing upper control arms, often abbreviated UCAs. Upper control arms are a critical component to any independent front suspension system as they control the movement of that tire as it cycles from the full compression to full extension position. Independent front suspension systems are found under most modern trucks and SUVs. That'll include your Tacomas, Tundras, F-150s, Silverado, Nissan trucks, 4Runners, Land Cruisers, basically anything that does not have a solid front axle. The upper control arm is found near the top end of the suspension system, and it works together with the lower control arm to determine the arc in which that tire moves, or more specifically, whether the tire moves forward, backward, leans out, or leans in. That geometry is typically preset by the manufacturer and is designed for a factory ride height, factory tire size, and typical use for the vehicle. If we're trying to increase performance, ride quality, and handling, or lift the vehicle, fit larger tires, get more down travel out of it, we'll typically need to make adjustments to the upper control arm. Unfortunately, most factory upper control arms are very limited, so that's where we'd need to replace the upper control arm with an aftermarket model. In this video, we'll discuss different types of upper control arms as well as their features. And the goal here is to help you determine whether you need to replace the upper control arm, and if so, which model and which features are best for your application. I'd like to start by showing you a generic replacement upper control arm. This is a Moog unit that I purchased on Amazon, and the whole thing cost me $40 delivered to my door. It's also very similar to what you'd find on most OE vehicles from the factory. It has a stamped steel frame, it has rubber bushings, and a generic cheap ball joint. So while nothing about this is fancy or heavy duty, in fact the ball joint and the bushings are non-greasable, this is actually more than enough for most applications. And the reason for that is because in an independent front suspension vehicle, it's the lower control arm that sees most of the forces. So as you're driving, let's say that you're driving at high speeds and you hit a pothole or a dip or a bump, those forces get transferred through the tire to the lower control arm, and as the lower control arm cycles, its job is to transfer that energy into the coil spring or the coilover or the strut. So the lower control arm handles the forces, and the upper control arm is left to do one thing, and that's basically to position that knuckle and cycle that suspension along the arc that's been determined. So very little forces come to the upper control arm. With that said, with larger tires and aggressive use, we have found that this style upper control arm will start to twist a little bit. Now, for $40, as you'd expect, there are other limiting factors. For one, the rubber bushings, while they are cheap, they move a little bit more. That's designed to isolate the small vibrations from the road and actually give you a more comfortable feel in the vehicle. However, if you're driving aggressively, you want to reduce those movements for a tighter feel. While these can be replaced with polyurethane bushings, you'll find, and especially if you're not doing the labor yourself, it'll be more expensive to replace those bushings with polyurethane than it would be to replace the upper control arm. You'll also notice that nothing about this upper control arm is adjustable. It's got fixed bushings and a fixed ball joint. Well, again, for most applications, that's more than enough, as long as we're using the factory adjustment mechanism. This is from a Toyota Tacoma, and we've seen these in a lot of applications. There are other styles, but I think this is the most common. And depending on how you turn these adjustment cams, that'll push the upper control arm out, it'll pull it in, it'll move the tire forward, it'll move it back, so you can get your adjustability using the factory mechanism. Now, once you get to larger tire sizes, larger ride heights, more down travel, that won't be enough adjustability, and you'll need an upper control arm that either has a built-in offset or offers more adjustability than the factory. We've talked about the frame itself. As you'll see in a little bit, aftermarket upper control arms have a stronger frame to prevent or isolate those forces. But the last thing that we'll find, and this tends to be the biggest factor with a generic upper control arm, is the ball joint ends up being a limiting factor. Not on all vehicles. Obviously a cheap ball joint will wear out sooner, so there are reasons to replace that with a heavier duty unit. However, on trucks like Tacomas, Tundras, Silverados, 4Runners, and a few others, the ball joint angle itself is the limiting factor. So as the suspension cycles downward, eventually that ball joint is going to reach its limit. Therefore, the coilover itself or the frame has to have droop stops. Something will need to stop the suspension system from going down any further so you don't damage this ball joint. If we go to a high misalignment aftermarket ball joint that we'll see in a little bit, that allows for more angle, we can actually get more down travel out of a suspension system just by changing the upper control arm. So as you can see, even though this only cost 40 bucks, for most street-driven applications with standard tire sizes, if all you're doing is you're changing shocks and not building a high-performance vehicle, a $40 set of replacement upper control arms is more than enough. Compared to a generic OE upper control arm, all aftermarket upper control arms offer significant benefits. First, the chassis mounts as well as the pivots are going to be higher quality, heavier duty. They also tend to be greasable, sealed, as well as either replaceable or serviceable. The inner area tends to be a lot larger, and this is to clear larger aftermarket coilovers, struts, and springs, as well as to clear them at a steeper downward angle. Also, because aftermarket upper control arms are often installed on vehicles with higher than stock ride heights, effectively a suspension lift, they have a degree or two of additional caster built into them, and that's to help you get a proper alignment with the suspension sitting at a new position. There's a bit of misconception there though. One thing that we get all the time is people that think that in order to fit a larger tire, you need to lift the vehicle. And I understand where that comes from, because if you've got a truck at ride height and you lift it up, let's say 2.5 inches, all of a sudden you've got a little bit more space within that wheel well. Well, the problem is if a tire doesn't fit at ride height, you lift the truck up, fit that larger tire, what you're forgetting is that unless you've modified the upper or lower control arms, that tire is still moving along the exact same arc, meaning it's going to pass the factory ride height position and move all the way up into the factory full compression position. It's cycling from the same full compression to the same full extension position. So lifting the vehicle does nothing for you to fit larger tires. In order to fit larger tires, we need to move that arc further forward within the wheel well to get it away from the back fender, which is where the clearance issues tend to happen most often. The way that's done is you take the lower control arm, and these typically have the same style alignment cams that I showed you earlier. You take the further back mount and you move it out. You take the furthest forward mount and you bring it in, effectively rotating that lower control arm forward. And 1/2 inch, an inch, 3/4 of an inch makes a big difference. So then, with the lower control arm moved forward, we need an adjustable aftermarket upper control arm that'll allow us to get the proper alignment with the tire now moving in a further forward arc. So that is why, in order to fit larger tires on an independent front suspension vehicle, you need an aftermarket upper control arm that offers the proper alignment adjustability. Aftermarket upper control arms are available in 2 main styles. First, we have what I call the racing series or racing style upper control arm. These are almost always made out of bent DOM tubing, welded to a cup that houses a spherical bearing, sometimes called a uniball, and at the chassis mounts you'll have adjustable heim joints. Now the idea here is to create a fixed mechanical connection from the knuckle through to the chassis. All of these joints, the spherical bearing and the heim joints, are effectively a metal-to-metal contact. Granted, there is a thin layer of Teflon in there, but they're designed to transfer every vibration, every movement, everything that knuckle is seeing through to the chassis so you can feel it in the steering wheel. And as such, when you're driving at high speeds off-road, being able to feel every little dip and bump and movement is going to allow you to make faster reactions. The other style upper control arm is what I call the endurance style upper control arm. It's designed for an extended life. It might have some more adjustability, it'll be stronger. Mainly it's designed for endurance. They're also going to have a very heavy duty frame. This particular one has DOM tubing welded to a forged center section. Some of them might be all forged, and some of them are going to be CNC machined from aluminum for that added cool factor. The endurance style upper control arm is going to feature a heavy duty ball joint, typically with more misalignment in the ball joint. It'll be greasable and it'll typically be sealed with some type of boot. At the chassis mount, this type of upper control arm is going to feature some style of polyurethane bushing, and the idea here is to isolate some of those vibrations. So as you're driving down the street or the highway or doing some off-roading, it's going to isolate these smaller vibrations for added comfort in the vehicle and through the steering wheel. Again, polyurethane is significantly firmer and it's going to have a longer life than the rubber bushings found in a generic upper control arm, so it's an excellent trade-off. And in fact, some racing style upper control arms will still retain the spherical bearing, but they'll use polyurethane bushings at the frame to try and get the best of both worlds. In any case, strength between the two is pretty much equal. One isn't going to be stronger than the other, as you'll see in a little bit. But the main difference between your racing style upper control arm and your endurance style upper control arm is going to be in the pivot. So if you've seen any of my other videos, you'll know that I really like cutaways. I love being able to see the inside of components. And that's because I think it's really the only fair way of being able to compare products rather than just reading down a list of marketing material provided by companies. I don't know how many times I've found those to be misleading or flat out incorrect. So what we have here are the 4 styles of upper control arm pivots that I'd say are either the most popular, most common, or we get the most questions about. We've got the spherical bearing that we saw in the camber style upper control arm, the racing style one. We have a Moog traditional style ball joint. We have the Icon delta joint, and then the SPC high misalignment greasable ball joint. And what we'll do is we'll start with the spherical bearing and work our way through. So I'll get these out of the way. And the spherical bearing is the simplest of them all. It's, as you'd expect in a bearing, you've got a ball, you have a race, that ball is pressed into that race, and in order to prevent it from being metal-to-metal contact, there is a Teflon liner in there. That's mounted in the upper control arm, and through that bearing, these are not matched for each other. This bearing is a little bit smaller than the Camberg one. But inside of that bearing, you'll have these misalignment spacers. And these misalignment spacers are designed to move with that bearing, and they're rounded at the top and bottom to allow that spacer to actually rotate further into that race. So you get a lot of misalignment out of this. You'll get more misalignment out of a ball joint style upper control arm for this reason, and that's why these are found in racing applications. You won't be able to use this much travel in your Tacoma or your 4Runner. This is going to be for your pre-runner trophy truck, real long travel suspension system. And that's the reason that they're designed this way. So the misalignment spacers fit into that bearing, and through that misalignment spacer, we have the bolt. So one drawback that we have here is that all of these are straight fittings. You'll see how that's a straight fitment in order to fit into that bearing, unlike the top, or I guess I should say the bottom tapered portion that is narrower at the bottom than it is at the top. This taper is what you're going to find on all tie rod ends and at your knuckle, because that angle, when it's forced into the knuckle, grabs really, really tight and prevents any bit of angle or slop. That's also why they're really difficult to remove. So when you're trying to remove that factory tie rod end, what you need to do is you need to take a really heavy hammer or a block of steel, put it up against one side of the knuckle, and hit it from the other side with a really hard hammer to get that opening to flex, and that is how you're going to get that ball joint to pop out. If you've ever tried to replace a ball joint before, you'll know that if it's been in there for a while and torqued down, it is very difficult to remove. But that's the reason that they're tapered. That's the reason that they're designed that way, is to prevent any sort of wiggle or play. Well, when you take a spacer like this that has a squared off insert and it fits into a square bearing, and then you have a bolt that goes through there, well, no matter how well it's machined, and this is of course one of those things that the more you spend and the higher quality component you get, the better it's going to be, but you're going to have just the tiniest little bit of play in there, and that's before it even wears out. So that's one drawback to this design. It is, however, very strong, at least as far as the bearing goes. These bearings, and this one's smaller than the Camberg, is rated into the tens of thousands of pounds. So the bearings don't ever break. They just tend to wear out. Some marketing companies will actually claim that their upper control arms are stronger than others because they've got a bigger spherical bearing in there. And that's not really the case, because no matter how strong or how big that bearing is, I mean, let's use a 4-inch bearing, you're still tapering it down to a grade 8 bolt. And this grade 8 bolt still has to taper down into the knuckle, so it's the exact same size as a traditional ball joint. So the strength is always going to be limited by the bolt or the ball that goes into the knuckle. So what happens with spherical bearings is because they're opened at the top and the bottom, there is of course that Teflon liner in there, but it is open. So water, dirt, calcium, debris, whatever you're driving through or around is going to seep into there. Well, as soon as those really small particles get in there and the ball is rotating and twisting, it's going to wear away that Teflon. What we tend to find is that on most street-driven applications, these spherical bearings need to be replaced somewhere on the average of about 3 to 4 oil changes. Some customers, they tell me that they replace them every 2 oil changes. I've had customers that have never replaced them and they just kind of live with it. But proper maintenance is replacing these every 3 to 4 oil changes. Now, there are things you can do to try and protect these bearings. Some companies sell plastic caps that fit in the top of the upper control arm. The problem with that is the bottom is still opened, and as you're driving the vehicle and as you're hitting puddles and water splashes up, it's still getting in through the bottom part of that bearing. Remember, it's open, it's the same on both sides. And that plastic cap on the top, as we find with shock boots and shock grommets, oftentimes does a much better job of holding debris in than it does keeping it out. There's only one solution that we've found that really increases the life of these bearings. It's not a very popular thing to do. And what that is to pack really sticky bearing grease, any sticky grease that you have, the stickier, the thicker, the better, and pack it all around that ball, top and bottom. Of course, as you're driving, dirt and stuff is going to pack around that and it's going to look pretty bad. However, as long as the dirt's on the outside and all you have is fresh grease touching that bearing surface, it's going to prevent anything from actually getting in between the bearing and the race, thus significantly increasing the life of that bearing. Well, another thing with these is they're designed to be, the reason that they use these in a race application is because they're a consumable part. It's something that wears out. You run them for a race or two, and then you replace them. For a street-driven application, that's a pain, mainly because unless you've got proper tools, and this is a spherical bearing puller, I believe this is made by AGM, All German Motorsports, very well-designed tool. This tool will allow you to replace that bearing while it's on the vehicle. If you don't have this tool, you actually have to remove the upper control arm, find a socket big enough, press it out, press the new one in there, and while racing style upper control arms look really cool, what we tend to find is after you've had to replace a spherical bearing twice or 3 times, you're normally done with it. So my recommendation is for a race series upper control arm that uses a spherical bearing, unless you want it for that cool factor, unless you want it for those Instagram likes, this is not something that I recommend for a street-driven vehicle or non-race application. So the next pivot I'm going to show you is the Moog Problem Solver joint. This is an upgraded version from the one that I showed you in the generic Moog upper control arm earlier. And at first, there are a few companies, quite a few actually, more and more, that use the Moog Problem Solver ball joints in their upper control arms. They don't always look like this. Some of them are a top bolt-in mount. I always thought it was kind of a cop-out. Let's just use a generic ball joint in our upper control arms. However, and this is why, again, I love cutaways, you learn things. Opening this ball joint was a huge pain. After going through a Sawzall blade and a bandsaw blade, I realized that these are hardened steel. And it's probably some of the hardest steel I've ever had to go through. So I used a cutoff wheel on a grinder and just kept going at it until it opened up from both sides. So that is heavily hardened steel. It's also very thick. Inside of this ball joint, let's see if we can take this apart. You have, of course, the ball itself. And we did hardness checks on these. I guess I'll just go through it now. The bearing is, of course, the hardest. That's bearing steel. So the hardness on that is stronger than all of the other ones. From there, the Mogh was the second hardest. The SPC upper control arm was after that, and then the Icon Delta joint was the least hardened. We're just talking about surface hardness here. I didn't actually open them up. But in the end, you're not breaking these balls. Unless the upper control arm is allowed to overextend, normally these balls will pop out of their sockets before you actually damage them. So strength on the ball joint itself is not really a critical factor. So inside of that housing, the ball joint sits at the bottom. On top of that ball joint, we have what I'll call a cap, and it's got some slots in there that I presume are for grease to go through, and it has a slot through the side that allows it to, I guess, compress and extend either through heat or through wear. At the top of that, we've got a spring washer that fits on top of that cap, and then we have the top plate, which does have an opening, and of course these come with Zerk fittings so you can grease them. So while I'm on that topic, and this is a good place to show that to you, the reason that you want a greasable ball joint is not to keep the ball joint lubricated. Obviously, having grease in the ball joint is going to help wear, but what happens is dirt, water, debris is going to get inside. It always does. You can't prevent that. Once that dirt and stuff gets in there, that is what is going to cause these ball joints to wear out prematurely. So in order to get that dirt, debris, water out of there, you have to press it out. So what you do is you put new grease in through the top until you see the old grease come out. That old grease is going to push all of those contaminants out of the ball joint, keeping it clean. So when you're servicing your ball joints, your tie rod ends, any sort of linkages that you have, you need to do that on a regular basis. Again, not for lubrication purposes, but to clean the joints and keep the debris out. So you want to make sure that any ball joint that you get has some sort of greasing port. So what happens is, as that wears out, the spring pushes on that cap and keeps all of that tight. And again, with as hard as these components are, they're going to last a very, very long time before they need to be replaced. So again, any upper control arm that uses a Moog problem solver joint, I'd be very happy with. They're extremely strong. They're going to get a long life. And not only that, they're relatively cheap. The pair of these were about $60 delivered to my door from Amazon, and they are some of the toughest ball joints I've come across. So again, these would be highly recommended, and they do typically come with a boot of one style or the other to try and keep stuff out, but make sure to grease them on a regular basis. From there, we're going to move on to the Icon Delta joint. And these are relatively new, and like with anything else Icon does, they've got a massive advertising budget. So as soon as they came out, they were in every magazine, every internet forum, and we started to get a ton of questions on these. So that's why I bought a set, cut them up, so I can give you honest recommendations. So the first thing that you'll notice is it's pretty much the same size as the Moog problem solver joint. The ball itself is pretty much the same size. You can see that there. Maybe a little bit bigger. The shank on that is a little bit longer. One thing that I really like on the Icon Delta joint is it's got a hex. I'm not sure if it's going to show up there, but it's got a hex. And that is really nice, especially if they've been on the vehicle for a long time and they've gotten rusted or seized. You can put a socket on that and that'll help remove that castle nut. So I really like that feature. One thing I'm not too sure about is Icon is the only company that I've seen use a coarse thread on the ball joint rather than a fine thread. I've yet to have a customer come to me with issues or tell me that they've damaged the Icon joint. It's just an interesting choice where it wouldn't cost anything extra to use a fine thread that kind of gives you a bit more torque on there, but not really an important thing. Again, the Icon joint doesn't have, you can see the markings on there maybe. It wasn't as hard on our hardness test compared to the Moog joint or the others, but again, you're not going to be breaking these. So as far as the design goes, Icon uses, these ended up being mild steel or mild steel housings. Also, you'll notice, and I'm not sure if it'll pick it up, the bottom portion of these where the ball sits is heavy walled, but near the top where you have the top cap and the spring, it's very, very thin. This particular ball joint, I just took a hacksaw, opened it up to remove the ball, so that is relatively mild steel. Again, no one's really breaking those, so I wouldn't worry about that too much. At the bottom, you're going to have this small seal, and that's of course going to help keep debris from getting in. Not sure how long that's going to last, but it's, I guess, better than not having one. We then have the bottom race, and I don't think this is hardened. My hacksaw managed to cut into that, so not necessarily super hard, but that is going to hold the bottom of that ball joint. And then on top, similar to the Moog, we've got a cap with a port at the top for greasing. Then instead of a metal wave, or I guess a metal
washer spring, Icon uses an O-ring, and kind of wondering why they used an O-ring rather than a metal spring. I guess in the end it's all the same, but that's kind of a curious choice. So we've got an O-ring in there that offers the preload, and at the top we've got the cap with the grease fitting in there. So that's the design there. Very cool design. One of the nice things about these is when Icon designed these, one of the purposes was to replace the spherical bearings in their upper control arms. Like we said, there's a lot of wear and replacement issues with the spherical bearing. So these, maybe it'll be easier to show it this way, and this isn't the proper part number, but you get the idea, are pretty much the exact same size as a spherical bearing. So if you've got an upper control arm with a spherical bearing and you're tired of replacing it, the Icon delta joint can take its place. And I think that's absolutely brilliant. I've actually been asking companies for years to come out with something like this, and I'm excited to see that Icon did. So overall, not as hard, not as heavy duty, probably not going to last as long as a Moog problem solver joint just due to the choice of materials. However, it's got a lot of unique features. We've got a lot of customers that have chosen to run these. The other thing to keep in mind is for a pair of these, you're looking at somewhere between $250 and $300 just for the ball joints, whereas a pair of Moog problem solver joints runs you $60. So when you're looking at cost compared to strength, ease of replacement, reliability, things like that, you get a lot more for your money using a Moog problem solver joint compared to the Icon delta joint. Very unique design though, and we know that they sell a ton of those. Lastly, I'm going to show you the SPC high misalignment, greasable, sealed ball joint. And these are, of course, the ball joints that you'd find in any SPC upper control arm. And the first thing that you'll notice is that the ball itself is massive. So compared to that Moog problem solver joint, you can see how much bigger the SPC ball joint is. Also, it's polished. Obviously, I've kind of cut into it and ground into it a bit, but the ball itself is polished, and that's going to help a lot with wear. The smoother the surface, the less the friction, the longer it's going to last. And again, very heavy duty. This was almost as hard as the Moog ball joint, so the hardness factor is up there. And again, that's going to help with wear. The SPC upper control arms use a very unique housing here, and I'll explain why this is offset in a little bit. But first of all, we have a plastic or nylon cap, and this is an interesting choice. Most of the other, if not all of the other ball joints use a metal race in there. SPC is designed to use plastic, and we've not run into any issues with them wearing out prematurely. They have a mechanical wave spring in there that's really tall, so that offers a lot of preload. And as well as if you're keeping it greased, constantly have enough grease in there, due to the increased surface area, this is going to be quieter and last a very long time. The housing itself, once I've cut it out, has very thick walls. So once that's pressed in there, these are not serviceable. I did have to cut into these in order to remove the components. So when these wear out, you just buy a new one. Luckily, they're surprisingly affordable, but they have very heavy walls to secure that ball joint into the housing. So now onto the really cool thing about the SPC upper control arms, or rather their joints. You'll immediately notice that we have a threaded shank up here through which we've got the Zerk fitting, and that of course runs through that and comes out through the bottom there to keep the ball joints greased. But the reason for this offset is the brilliance of the SPC ball joint design. So if you remember how we mentioned earlier that an adjustable upper control arm is the key to fitting those larger tires and getting that higher ride height that you want, along with getting the proper alignment, well, that's exactly what SPC upper control arms and their ball joints are designed for. So this is the bottom side of an upper control arm, and you'll notice that it has this slot. Well, on the SPC ball joint, we've got a hex machined into it right underneath the threads, over which this rectangle piece of steel with that star shape in it fits. Well, that rectangle slides perfectly within this groove, and with the ball joint being offset like that, when we put it into there, obviously this is upside down, you'll notice that we've got a lot of movement. Moving that ball joint, in this case forward and back, that's going to allow you to adjust your camber. And then if we rotate the ball joint within that star, you'll notice that it will settle in once it finds its angle. And you can rotate it backwards. And between these changes, as well as sliding it forward and back, you've got close to, if not more than 4 degrees of adjustment in each of your directions to get that proper alignment. So now, of course, on the top side of that ball joint, you'll see how that slides. And once you take your vehicle for an alignment, and I guess while I'm on that subject, one of the first things that my customers ask me when they get all these parts is, well, who should I take it to? Where do I need to go to get these installed? And any reputable alignment shop will be able to do this for you. There are 2 questions I tell all of my customers to ask when they're calling an alignment shop. And the first is, tell them what you're looking to do. Say, I've got a 05 Tacoma and I'm trying to fit 33-inch tires. See what their response is. If their response is, well, we normally do Honda Civics, but sure, bring it by and we'll give it a shot, go somewhere else. If you ask them, can you help me fit 285s on my 4Runner with my aftermarket upper control arms, and like, yeah, bring it over, we do it all the time, you're in much better shape, most likely. The second question I have my customers ask is if they know how to align SPC upper control arms. Even if they're not running SPC upper control arms, I have them ask, do you guys know how to align SPC upper control arms? Any reputable alignment shop should say, yes, we do them all the time. And the reason is SPC is not a small company. They're a massive company. Upper control arms are only a small portion of what they do. They teach classes, they sell equipment. They are a massive company in the alignment industry. So if you reach out to an alignment shop that's never heard of SPC, chances are you probably want to go somewhere else. Otherwise, if it's a shop that you've worked with before and you trust them, SPC has excellent technical support. They've got great YouTube videos, although, I mean, this is pretty much how they work and they come with instructions. They are very easy to adjust and align. Once you've found the proper angle and the proper positioning, a heavy-duty washer goes on the top, and then a really heavy-duty nut goes on top of that. Of course, it keeps that top Zerk fitting open so you can continue to maintain it and grease it. But once that's torqued down really tight, that's not going anywhere. So now you have an upper control arm that has a very heavy-duty ball joint. It's sealed. These boots are extremely tough. If you happen to tear one of them or damage one of them, we've got a box of them here. We'll send them out to you. But very heavy-duty, it's sealed, it's greasable, and more importantly, it allows for a lot more adjustability in addition to the traditional style alignment cams that you would use at the frame mount. Well, I hope that this video helped answer a lot of questions that you may have or didn't know that you had about upper control arms. This video should cover, I'd say, about 95 or more of the upper control arms that you'll find out there. Obviously, there's a ton of different brands done in a lot of different ways, but you'll find that they're going to be a combination of the pivots and mounts and arms that we've showed you here. Obviously, if you have any questions, make sure to leave a comment under this video. We read all of the comments and respond to as many as we possibly can. Also, you can find a lot more information on our website, filthymotorsports.com, or send us an email. That's sales@filthymotorsports.com. Also, if you like this video, give it a thumbs up. It really helps us out. If you didn't like the video, give us a thumbs down and tell us why you didn't like the video in the comments below. We want to know what we can be doing better. I know that we've been away from YouTube for a little while now, but we've got a lot more videos in the works, and we want to make them as helpful to you as possible. So make sure to subscribe. That way you're going to be notified of new videos that are coming out. And as always, I'm Ben with Filthy Motorsports, and thanks so much for watching.